Assalamu alaikum students. Today I am going to explain you how to shade the regions while doing sets. You remember when we did sets, guys, we saw two sets categories and three sets categories, right? Two sets category means he gives you a universal set and he gives you two overlapping sets A and B. And in three sets categories, he gives you three overlapping sets, A, B, C. And rectangle shows universal set. If we look at two sets category, we have four regions, 1, 2, 3, and 4. And in three sets categories, we have 1, 2, 3, 4, 5, 6, 7, and 8. 8 categories we have. Normally, we see the examiner gives you questions in two sets and three sets. He may change the questions, like he can, if he is using three sets, two sets are overlapping and third set is not overlapping. But in normal routine, this is the situation which I have drawn in front of you. Yani, two sets and three sets. Before I go to explain shading, why not we can just revise quickly what is A dash. A dash is called complement of set A. Or in other words, A dash means outside of A. Suppose I have a universal set and I have a set A. Okay, so I have a set A, universal set. This is a set A. Now, as you know, if I shade the circle, it means that I'm talking about the set A. But if I'm interested in A dash or A complement, so I need to shade the portion which is outside A. This is complement of A. Some people call it as U minus A. And you subtract the elements or the area from the universal set, and the remaining one is called complement of A. Now, there are two operations very important for us to know when we do sets. U, it stands for union. It is much easier. So if I give you set A, 1, 2, 3, 4, and if I give you B set 3, 4, 5, 6, 7, I am not interested that what are the common elements. Rather, I will try to copy all the elements of both sets. But keep it in your mind, if 3 is repeated twice, in the set, you are not allowed to write any element more than one times. So only one time. And also in sets, order is not important. So 4 was seen twice, but we wrote it only one time. Now, if I want to show them on the Venn diagram, the union, I can simply draw a circle, two circles, A and B. And I will write the common elements here, 3 and 4. 1 and 2 are only in A. 5, 6, 7 are only in B. So this is the way we can show the sets diagrammatically, and that diagram is called Venn diagram. So today what we want to learn, we want to learn without elements, areas, which region we have to shade when any specific operation is mentioned. So first thing is A union B. So when I use this word A union B, it tells me I need to take complete A and complete B. So let me show you a diagram. I have a circle A, I have a circle B. So from the meaning of universal set, I have to take complete A, I have to take complete A, and then I have to take the complete B. Doesn't matter that there is a portion which is common with both sets. But union says when you see the union, it means you have to shade complete A and complete B. Now, let me explain you another thing. If you have A complement union B, then again, it's very easy. I have A and B. As I said, that you have to look for what is in between union. So you have to shade complete B. Allow me to shade complete B. I'm going to do that. Complete B is shaded. Done. Now I have to shade outside of A. Now outside of A is which portion? This portion is also outside of A. Let me reshade this blue part. And this portion is also outside of A. Just you need to avoid the circle of A and shade rest of the region within this rectangle. So this is A complement union B. Now, if he says A complement union B complement, very easy. Be careful, guys. You have to know which operation is used in between union. So union means all. So can I shade B complement first? As I said, complement means outside of B. So avoid the circle of B. Don't go inside. You have to shade everything outside. So I'm going to shade everything outside of the circle B. Right? Now, after doing this, I have to shade outside of A. So outside of A, I have to go outside of circle A. So which portion is left? So this portion is left. It means this is the portion which is represented by A complement union. Yani this portion was not shaded, sorry. Yani the intersection portion is not taken, but rest of the portion is shaded. This is called A complement union B complement. Clear? Before I explain you A intersection B, why not I can explain you the concept of complement, repeated complements. Yani if I have complement of A, it means outside of A. But if I write complement and then again complement, so complement and complement cancel each other and you get A yani inside of A. So suppose if I'm writing A complement, 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 and complement. Pretty easy. So this complement cancel this complement, and this complement cancel this complement. So what is left to you? A. Or when I say A complement, it means I am outside. But when I say again take complement, I go inside. If I take again complement, then I go outside. So if you have even number of complements, it means you are A. But if you have odd numbers, yani if I have odd dashes, then my answer is A complement. But if you have even complements, then you have A. I hope it is clear to you. Now, there is a very important rule which is called De Morgan's rules. It's not in your course, but I want to explain you. It will help you to shade the regions very well. Suppose if I have A union B complement, it is the same like if someone has X times Y raised to the power 2. So in algebra, we studied this square goes here. So I'm going to write here X squared. And then we write here times Y squared. But this square doesn't affect multiplication. But in sets, this is very interesting. When I share the power with these three, so A gets the complement. The complement of union is intersection, and the complement of intersection is union. Be careful about it. So this union will turn into intersection, and then we have B complement. Let us try to solve the case if I have A complement union B complement, and then gonna take complement of that. Interesting. Now this complement is gonna go to this one. So I have A complement and complement. Then what is the complement of union? That is intersection. Now I have to take B complement and complement. Everyone knows even number of complements gives you A, even number of complements gives you B. So look, very difficult set notation is converted into simplified version, so which is A intersection B. Now, if I have A intersection B complement and whole complement, can I apply the rule, the De Morgan's rule? Yes, this complement goes on A, it becomes A complement. Complement goes on intersection, it turns into union. And then complement of complement, this is A complement union B. So I will again try to explain you how many combinations of union for two sets category you need to memorize. A union B you need to know. A complement union B you need to know. A union B complement you need to know. And A complement union B complement you need to know. So A union B is basically complete A and complete B. A complement union B, as I said, union means you need to shade the complete B and outside of A. Clear? And this is basically equals to, I will explain it later, what this is equals to what if I want to convert the union operation to intersection, then it will be A intersection B complement like that. But no need to go into that details. And if I'm going to talk about this, A union B complement. So this is A. I have to shade complete A and then outside of B. Now, A complement, union B complement, very famous. I can write it as A intersection B complement, which is, I have to shade everything except the overlapping part. So, boys, I have covered with you the cases of union. Now we come to the intersection part. A intersection B. So, intersection tells you common regions we have to take. If I have a circle A and circle B and there is a universal set, intersection tells you you just need to take the common region. But today I'm going to teach you another way. What is that? In the case of union, I told you shade everything for the set which is on the left and the whole set which is seen on the right. But here I will not advise you to do the shading. So don't do the shading once you see intersection. You have to use a dot method. So choose any easy set, maybe left, maybe right. So I dot. So A set is constituted on, yani the circle A of A has two regions, this one and this one. Interestingly, if you look at this dot, this part of A is common with B. And this part of A is not common with B. Okay, so can I name these regions? This is called A intersection B complement because this is coming outside of outside of B. And this part of A is common with B. So I want to take that dot which will, you know, coming in B. Suppose I want to show you A intersection B. Now, A intersection B means I have a circle. The Venn diagram. What I have intersection in between. So I need to go for common. So use a dot method. I'm using dots on B. So this is B and this is B. Now, which dot I have to take? Check which dot is in A. This dot is in A. So just shade that and ignore the other one. Now, if I give you, I'll draw two diagrams. Yani, I have A. Hold on. If I have A intersection B complement, if I have A complement intersection B complement, why not? We can look at their Venn diagrams and which region I have to shade. This is universal set. Now, which operation is in between? Intersection. So don't shade. Use a dot method. B complement is a little bit hard. Why not? I can use for this part, this region, I put a dot because it is coming in A. And here I put a dot because that is also in A. Now check that which dot is outside of B. So this dot is outside of B. So I'm just going to shade that one. Don't try to shade that region which is not considered in the dots. Let's do the other question. Again, we have intersection. So I'm going to use dot for B. So B complement, this portion and this portion is coming in B complement. Now, either I take that part which is coming in A or I take that part which is coming outside of A. So since the guy has written outside of A, it means this dot should be considered because if I shade the other dot, that will take me to in the A. I hope it is clear, guys, because you remember in a Venn diagram, we have four regions. Again, 1, 2, 3, 4, four regions. So out of the four regions, you need to shade the regions. So when I'm trying to shade region 1, so I have to shade everything here. If I want to shade 2, this portion. If I want to shade 3, region in overlapping part, or 4. Now we can start solving the questions which are already given to us. Number 1, you can look at that. I am taking A. So A means this portion and this portion. I have to take both because a circle, a complete circle of A has to be shaded. Now come to the B. In this Venn diagram, I have to shade the complete B circle, that region which is showing the B set. A complement. So I have to leave this part and shade this part and this part because the blue area where I have put the check mark, that shows outside of A. Now look at the B complement. I have to go outside of B. Now this portion is in B, this portion is in B, but this portion is outside of A and this portion is outside of A. So I have to shade outside of A region. Now A union B, as I said, whenever you see the union in between, you have to shade complete A. I shaded A. Then he said, like, I have also to shade B. So I shade the B part. So then you see the blue colors in front of you. Whenever I have intersection in between, so I have to keep focus on one of them. So I put the dot on A's, so this and this. Then after that, which dot is coming in B? Only this one. Now, which symbol is in between? Union. Union tells you we have to shade complete A. I'm going to shade A. And then he said you also have to shade outside of B. This is inside of B. This is inside of B. I have to shade outside of A and outside of it. So guys, can you see where I put the check marks? I just shaded that region. Maybe you think like, Mr. You put a cross there in the overlapping part, but can you imagine that there is a check mark there? So if there is a single check mark in the case of union, you have to consider that part. So union, it means I have to take complete B. So I take the complete B, and also I have to take complete outside of A. So outside of A is this part and this part. So it is in front of you now. I have shaded this. Now intersection, we have to use a dot technique. So I put a dot, two dots, one outside of B and one inside of B within the circle A. So is he looking for outside of B? So I will go only with this one, and I'm not going to take this part because the cross part is coming in B. Now come to the next case, we have intersection. So we use a dot technique. B, okay, this is in B, this is in B. Now, which portion we have to take? We have to take that portion which is going outside of B. So we put the dots here. We could put the dots here. So don't take this one and take this part because we want to be within B. Next is we have again intersection. Outside of A, use a dot method, put a dot here and dot here. Which dot I have to consider which is showing outside of B? So this dot has to be considered. Next, we have a union in between. Don't worry. Outside of A, complete shade outside of A is this and this. And outside of B is this and this, which is already taken. So guys, it is in front of you. I shaded the things. Now, you might be thinking why I wrote this. Because I applied the De Moivre's rule. Anyhow, if the guy has given you A intersection B whole complement, you can write it as A complement union B complement. I have already explained it to you. Now it's up to you. You can take A intersection B first, okay, and go outside. So you will leave that portion. But some students, they will follow this way. They will shade A complement first. So this is A complement, and then they do B complement, right? So they shade that, and same answer will come to you. Now, if I have here A union B whole complement, can I apply the De Morgan's? So apply the complement inside, and he gave you A union B complement. So I write A complement intersection B complement. A complement tells you that I have to put a dot on A complement. So put a dot here, put a dot here. And now which dot I have to consider which is coming outside of B. So this has to be taken. So I've just shaded this part. Now the guy has written A complement intersection B whole complement. Apply the De Morgan's complement. Complement gives you A intersection of complement union and B complement. So A complete and B complement. So we have to consider outside of B. So this was already shaded. That's the case. De Morgan's A complement union B. So A complement union B, A complement is this and this, and union B. you have to consider this and this, and then you shade it. Then A complement union B whole complement. So you get A intersection B complement. Now we have intersection between, use a dot technique, put a dot here. So which portion I have to consider? That portion which is coming outside of B. So I'm going to just take this. A union B complement whole complement. So I'm going to write A complement intersection B. So A complement means I consider this part and put a dot here, this part and this part. And which portion I have to consider, which is coming inside of B. So I'm going to just shade this. Next, he gave you A complement union B complement and complement. So I will write A intersection B. If I apply the De Morgan's. Now A intersection B, everyone knows this is the part. Now I have A complement intersection B complement and the whole complement. Apply the De Morgan's. So A union B. So I'll just take this part. This is interesting. I will do this one separately and this one do separately. See what is the letter in between, union. So A intersection B, I know this is the part. And A complement intersection B complement is this one. This is A complement intersection B complement. And this is also called A union B complement. So I just shade the blue part and the yellow part. Now union, I have to shade A intersection B. I did it. A intersection, this is A intersection B complement, and I shade this one. And this gives you complete set A. That's why I wrote my final answer as A. Now, what do you have in between? Union, intersection, so I did it. And then A complement intersection B is this part. I take this one. So both check marks are showing the region B. That's why I wrote this, both of these sets, they will be equal to the set B. Now we have intersection in between. We need to use a dot technique. A union B, I put a dot here. And then also we have A union B, any three dots we have for A union B. And check that which one is coming outside of A, union outside of B. So this portion is coming outside of B. Also, this portion is coming outside of A. So out of the three dots, we have to pick the two dots. Next is he gave you intersection in between. I use a dot technique. So A union B, put three dots. This is done. Now, out of these three dots, which dot I have to consider? Look into this. Is this dot is A? Yeah, union B complement? Yes. Is this dot is also complete A, union B complement? Because of the A union, yani I have to consider both of the dots. And B complement, it is this one. I cannot go outside, guys, because I know this portion is also B complement. But both of these dots are representing set A. Now, intersection, I have to use a dot technique. So A union B, I put three dots, guys, three dots. Now, A complement union B, take the complete B. And A complement out of them is, no, I cannot take this. I cannot take this because there is no dot here. So the answer is set B. Next is union. Okay, I can shade complete A intersection B complement. You know, this is A intersection B complement. I shaded it. And also I need to consider A complement intersection B, this part. Next, we have a union. I have to consider A intersection B. I took it. A union B complement. So I'm going to take A and also the B complement. A intersection B, there is a union. Excellent. Shade everything which is in A intersection B. And A complement outside. This is A complement. This is A complement. And union B, yes. So we need to shade those which are shown through check marks. This is interesting. Interesting. Why? Because there is a intersection. A union B is this, this, and this. But unfortunately, the other set has not taken any dots because this is outside A complement intersection B complement. So the answer is equals to 5. Now, sometimes in opposite, the examiner gives you a shaded part and you have to write the set notation. So as he has shaded complete A, we wrote the answer as A. As in this case, he has shaded the complete B, our answer is B. As the guy has taken complete that region which is outside of A, so this is called A complement. This case, the guy did not consider the circle B, but shaded everything outside of set B. That is called B complement. He took here complete set A and complete B, so which is a union case. He took the common part, A intersection B. Now, this is interesting. He took the part of A. That's why he used intersection. Now, two dots here and here. He take that part of A which is outside of B. So this is called A intersection B complement. A intersection B complement. Now, the next case, you see the guy has taken not complete B, he took the part of B. That's why he wrote B intersection. Now I use two dots. So which part of B he has taken, inside of A part or outside of A part? He is taking outside of A part. So I'm going to take this. Another important point, the guy is ignoring A union B. So I write here A union B whole complement, or through De Morgan's laws, you can also solve that A complement intersection B complement. So this is interesting, A complement intersection B complement. Now in this case, oh wow, the guy is taking complete A. So you cannot take intersection, you should take union. And also I want to take outside of B part. So write here A union B complement. Don't try to write A intersection, because the moment you write A intersection B complement, you are taking the part of A. But here in this case, he's taking the complete A. That's why he wrote A union B complement. The next question, you see guys, he has shaded the complete B. So no need to write B intersection. You should write B union. And did he take outside part also? So write A complement. Excellent. Now, he is not taking complete A, complete B. He is taking a part of A, a part of B, and outside. Now, Mr. Omar, this is like why you use a union. Yeah, Sheikh, it's easy if you consider this part. Can you imagine this is this middle portion is a very famous A intersection B. He's just ignored that. So he took the complement of this and he A intersection B outside. But if you want to give your answer in union, yes, I can tell you that you guys can take the B complement. Okay, the B complement is this one and this one. Union A complement, this and this. So imagine this is also giving the same answer to you, because it doesn't consider the intersected portion of A and B. So both answers are correct. Either you write B complement union A complement, or you write B intersection A home complement. Same answer comes to you. Wow. Now we reach to the three sets categories. So let's talk about three sets. As I already told you, there are 8 regions if all the three sets overlapping. 1, 2, 3, 4, 5, 6, 7, and 8. There are 8 regions we have. Now let me draw the diagram again and try to show all the regions. Ready? So this portion is, this is a universal set. Okay, this portion is only A, this portion is only B, and this portion is only C. Now come to this case, the intersected part. This intersected part, why not? I can make big diagram, and then within the spaces, I will write their set notations. Let me make big set. Okay, so this is your A, this is B, and this is C, and this is your universal set. Now this common part is called A intersection B intersection C. Agreed? Okay, since this part is coming outside of B, but it is inside of A and inside of C, so A intersection C intersection B complement. Now this part is the common part of B and C, but it is coming outside of A. I write A complement intersection B intersection C. Now this part is common with A and B, so I'm going to write A intersection B, but coming outside of C. Now this is inside of A, outside of B, and outside of C. This portion is outside of A, inside of B, and outside of C. This portion is outside of A, outside of B, and inside of C. This portion is outside of A and outside of B and outside of C. And I can also write it as A union B union C complement and apply the De Morgan's. You can easily get the result like this. So I have named every region to you. In the exam, you can easily understand out of the 8 regions which region he is talking about. So let's go into it. The first one, you see, guys, he took the common part, yani A intersection B intersection C, the middle one. And then you can see he takes A intersection B, but outside of C. So this is the portion which is A intersection B intersection C complement. Now he's going outside of B. So that's why he has shaded this part. But he has to stay within A and C. Next one, he has to stay within B and C, but going outside of A. And so this is the portion, guys, which is common with B and C, but outside of A. Then, interestingly, he wants to go only in A. This is called the only A situation because it is outside of B and outside of C. Only B, this is the portion which is common with B, but it is not coming in A and not coming in C. Now, he wants to take the only C region, which is outside of A and outside of A and outside of B. Now, he wants to go completely outside. So that's why he wrote A complement intersection B complement intersection C complement. Now, come to this case, union. There is a union. Union means I have to shade complete A intersection B. So he has shaded this part and this part. And then he also has to shade C. So I shaded this region. What is in between, guys? Union. Union tells you need to shade everything of A intersection C. So this is A intersection C, and this is also A intersection C. Also, you need to shade B. This, and this. So that's why we did it. Now, union tells you shade A complete. I shaded this, and this because all these 4 regions are coming in A. And also, along with that, you need to shade B intersection C. So this is B intersection C. Next, there is an intersection in between. Don't shade, but use a dot technique. So C, for C, I use a dot. 1, 2, 3, 4. Out of these 4 dots, there are 3 dots which are coming in complete A and B. So you need to shade them, shade these 3. If you look at the case here, we have intersection, use a dot technique. So I put dot in the 4 regions of B, 1, 2, 3, 4. Check that which dots are coming in A union C. This is coming in A union C. This is coming in A union C. This is coming in A union C. I'm not talking about that A union C independently, but you need to look at those dots which are common with A and C. So I put 3 dots out of the 4 dots. Now we have again A intersection, use a dot technique. So look at that. I have named the regions 1, 2, 3, 4. Now out of 1, 2, 3, 4, which regions are coming in B union C? So 2 is also coming, 3 is also coming, and 4 is also coming. So you just shade that part. Now intersection again, B complement, C complement. So C complement, what are the regions, we have it. I think I use a dot technique for A union B. So pick this, 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 this. So we have 6 regions, guys. Now, which of the regions are coming outside of C? So 1, 3, and 6. So that's why I have shaded that part. Now we have next intersection. Use a dot technique. In a dot technique, I need to take A union C. So you guys can see 1, 2, 3, 4, 5, 6 regions I have. Now, out of these regions, which regions are coming outside of B? So 1, 3, and 5 regions are coming outside of B. Then we got to go to the B union C intersection A complement. There is an intersection in between. I use a dot technique for B union C, 1, 2, 3, 4, 5, 6. Okay. Which regions are coming outside of A? 2, 4, and 6. We shade them. Now, instead of intersection, we have a union in between. Very good. I'm allowed to shade the A intersection B. Okay, shade it. And also shade everything outside of C. So we shade them. Again, we have a union in between. We are allowed to shade intersection C, and we are also allowed to shade outside of B. Okay, right? So we did it. I think I forgot. A union. No. There is no need to shade this part. Let me check it again. A intersection C, we did it. And outside of B. Yeah, don't shade this part, guys. The A complement. So A complement, as we see, union in between A complement, I need to shade this, and this. This is A complement, and also B intersection C. So where is B intersection C? Then we shade. Next, we need to write the notation. Everyone knows this common part is called A intersection B intersection C. This portion is called A intersection B intersection C complement because it is outside of C. This portion is coming outside of B, but inside of A, inside of C. This portion is coming inside of B, inside of C, but outside of A. This portion is completely within A, within B, within C. That's why I used A union B union C. This portion, he covers complete C. That's why I wrote C union. I want to take this part, so A intersection B. Guys, you can see now I have taken the complete B set. So that's why I wrote B union along with what? A intersection C. I'm taking the complete A set. That's why I wrote A union. And I'm taking the intersection with B and C. Next, he is taking a part of C. So which part of C he's taking, which is common with A union B, which is common with A and A union C. He's not taking the complete B, but he's taking that part of B, which is common with A union C. He's taking that part of B, which is A union C. He is not taking the full A, but he's taking the part of A. That's why he used intersection. So A intersection common with B union C. Last but not the least, the outside, you can also call it as A union B union C and put a whole complement. Or you guys can see A complement intersection B complement intersection C complement. And this is A complement. Let me write it here. This is A complement intersection B complement intersection C complement. So that's all, guys. I hope you understood very well how to shade the regions. It's not very difficult. And the whole concept of shading is explained within this lesson. As far as elements, if they belongs to a set, and you can see now there is no yellow here, so I'm going to say yellow doesn't belong to the set G. And when element of a set is related with a set, we use this sign belongs to or doesn't belongs to. In this case, you see 20 is in the set F, so I'm saying 20 belongs to F. Now, in this case, you see MAT and N is MATH, then can I say M belongs to? No, I cannot say M belongs to. Set always a subset of a set. I cannot say set belongs to a set. No, that's wrong. Element can belong to a set. So I have a set and I have another set. So do you see that all the elements of set M are contained in set N? It shows N is a bigger set and M is the smallest set. So I can say M is a subset of N. Now, in this question, he said X is odd. Can I write all the odd numbers? 1, 3, 5, 7, and 9. And here in the Q, he write 1, 3, 5, 7, 9, and 11. So can you check, are all the elements of set P, 1, 3, 5, 7, 9, are contained in set Q? The answer is yes. So set P is a subset of Q. Now, next is, can I check 2, 3, 2, 4, 6? So 2, 4, 6, yes. A is contained in B, so I can say A is a subset of B. You can check that B has no relationship with A, and B is bigger. How can I say B is a subset? So if B is not a subset, you guys can simply write in the exam B, the subset notation, and you just cross it out. B is not contained in A or not a subset. So we use here A is a subset. We use here E, and mango is one of the element of a set, so B belongs to E. Then you see all the prime numbers less than 10, 2, 3, 5, 7. Then 9, can I say 9 belong? No, 9 is an odd number. It's not a prime number. So 9 doesn't belong to the set D. There is a number 5. No 5 is here. So 5 doesn't belong to the set C. B, set B, A, E, I, O, U. So A is a vowel. Okay, so it belongs to the set B. 1, 2, 3, 4, 5. No, 6 is not there. So 6 doesn't belong to a set A. So overall, guys, these concepts are also explained to you. If you have a universal set and you have E set, and you can easily write a complement of a set, check that, is there anything common with E and complement? No, a set and its complement are disjoint sets. There is nothing common. Whenever I try to take their intersection, I will always get a phi. So D intersection D complement is always phi without looking into the set. C intersection C complement is phi. B intersection B complement, it's phi. A intersection A complement, it's phi. But be careful, guys. If I'm saying A union A complement, that is a universal set. But A intersection A complement is phi. So intersection is nothing, but their union is always giving you a universal set. That's the thing. The rest I have already explained it to you in the class. Hopefully that you will get benefit of this important video. And inshallah, do let me know if more videos are needed. I will create for you guys. Thank you. Assalamu alaikum.